Hello everyone! This is our fifth lecture for Chapter 6. In this lecture video, we will summarize the rules of probability and explain how normal distributions, z-scores, and probability are related. So here's the summary for the rules of probability. 1. The probability of any event must be between 0 and 1 inclusively. 2. The sum of the probabilities for all of our outcomes must equal 1. 3. If A and B are mutually exclusive events, then the probability of A or B is equal to the probability of A plus the probability of B. If they are not, so number 4, if they are not mutually exclusive events, then the probability of A or B is equal to the probability of A plus the probability of B minus the probability of A and B. 5. If A and B are independent events, then the probability of A and B is equal to the probability of A times the probability of B. And then the last one, if A represents any event, then the complement of A, or A prime, represents the complement of A. Then the probability of A prime is equal to 1 minus the probability of A. In previous lectures, we talked about normal curves and normal distributions. Normal curves are ways to visualize the distribution and provide a map to understand the relationship of any score relative to other scores. Remember that the normal curve shows where the scores are relative to other scores. The height of the curve shows how frequently these scores occur. The normal curve also shows how many scores fall above and below the mean and other scores. It provides us a map to understand relationships of any score relative to all the other scores in the distribution. It's really a great way to visualize the distribution. Here's a graphical representation of what we just reviewed. As you can see, this is the distribution for ACT scores. Most of the scores are near the center or the mean, and fewer scores are in the tails. The scores are understood in terms of their relative position to the mean. Remember that most social and behavioral data approximate a normal distribution. Remember the characteristics of normal curves? They are 1. Normal curves are symmetric around their mean. 2. They have united central tendency. And 3. The areas under the curves are known. The total area is always equal to 1. So let's review the first characteristic of normal curves. They are symmetric around their mean. What does this mean? Well, the mean divides the distribution into 2 equal halves. The halves are mirror images of each other. If you fold a normal curve in half, both sides of the curve would overlap. This means that what happens on one side of the curve is the same that would happen on the other side. The second characteristic of normal curves is that they have united central tendency. What does this mean? The mean, median, and mode are the same value. If you know one, then you know them all. The mean is also the most common or typical value in the distribution and is the 50% point of the distribution. It divides the distribution exactly in half, where 50% of the data will fall below the mean and 50% of the data will fall above the mean. The mean of normal distributions can equal any number from positive infinity to negative infinity. Remember, though, that the mean of the standard normal distribution is always equal to 0. The third characteristic of normal curves is that their areas are known. All normal curves are defined by their means and standard deviations. This figure shows the standard normal curve with its mean equal to 0 and its standard deviation equal to 1. The standard deviation divides areas into sections so that we can determine the area or probability under the curve at different points along the distribution. The total area under the normal curve is always equal to 1. The area under the curve has the same characteristics as probability. It varies between 0 and 1 and can never be negative. The standard normal curve is called the standard normal distribution, or Z distribution, which has a mean of 0 and a standard deviation of 1. Scores on the x-axis in a standard normal distribution are called z-scores. Remember that z-scores can be created for any set of raw scores. This is what we mean when we say standardized scores. Z-scores tell us the exact location of a raw score from the mean in terms of standard deviations. For example, if I have a z-score of negative 1.46, I interpret this as this raw score is exactly 1.46 standard deviations below the mean. We use the Z distribution or the standard normal distribution to locate where a raw score would be. We also use the Z distribution or standard normal distribution to determine the probabilities of any raw score in relation to other scores. We can determine probabilities for observing scores greater than, less than, among the top or bottom percent, or the likelihood of scoring between a range of raw scores. The standard normal table, also known as the unit normal table, or z-table, is a type of probability distribution table that gives us z-scores and their corresponding probabilities, or proportions of area, associated with each z-score listed. This table allows us to figure out the area under the normal curve at nearly every position on the normal curve defined in z-scores. The unit normal table in Appendix B1 of our textbook gives proportions of area under the standard normal score under the standard normal curve for z-scores ranging from 0 to 4. Each z-score divides the curve into two areas to the left and to the right of the z-score. Here is what the unit normal table looks like. The first column, A, is the z-score to the hundredths value. The second column, B, identifies the proportion in the larger section called the body. The third column, C, identifies the proportion in the smaller section called the tail. The fourth column, D, identifies the proportion between the mean and the z-score. The area is given in terms of proportions, which can be converted to percentages. The unit normal table can be used in three ways. 1, to find the probabilities from z-scores. 2, to find z-scores from probabilities. And 3, to find percentile ranks. A percentile rank is the percentage of individuals in the distribution who have scores that are less than or equal to the specific score. Let's say you scored in the 97th percentile of SAT scores. This means that you scored higher than 97% of students who took the SAT that year. Or this means that 97% of students who took the SAT that year scored lower than you did. Probability questions can be rephrased as percentile rank questions. This concludes our coverage for Chapter 6.